All right, ladies and gentlemen, we are looking at inverse trig functions. Our objective today is students will learn how to do word problems using the inverse trig functions. We've done this before with trig problems where it was the regular trig problems. Now we're going to use the inverse. You guys know that there are state standards. This is a state standard. It's usually at the top of your notes. It's not on the top of yours today, so I put it up on the board. We're using trigonometric ratios and Pythagorean theorem to solve right triangles and apply problems. Okay, so we are looking at these trig problems. So we've got a 25-foot ladder that's leaning against a building. The ladder's base is 13.5 feet from the building, finding the angle which the ladder makes with the ground. Okay, what is the first thing that we should probably do? Draw a picture. Okay, so we've got a ladder. So does the ladder lean straight up and down against the wall, or is it's angles? It'd be the hypotenuse. Good. Okay, we know that it is 13.5 feet from the base of the building. So where would that 13.5? On the bottom or on the side? Bottom. Oops. Okay, so we know our 90-degree angle is right here. We want to find the angle which the ladder makes with the ground. So where would I like to call it x, where would my x be, my angle? The one down at the bottom or the one up at the top? Bottom, because it says with the ground, right? Okay. So what is 25? Somebody just told me before that it's the ladder, it makes a hypotenuse. So what's 13.5 to that angle? It is the adjacent. Everybody should be writing this down. David, come on. David, sit up and write this down. Okay. So, ladies and gentlemen, we're looking at adjacent and hypotenuse. So I like to write SOHCAHTOA at the top of my paper each time. And it's cosine. So the cosine of x equals adjacent over hypotenuse. So then we stick this in our calculator. We go the inverse because we're looking for an angle. Inverse cosine of 13.5 divided by 25 gives me approximately, let's round to, what do you say, 2 decimal places sounds good? 100th place? We get 57.32 degrees. Pretty good? Let's do, what do you say, one more? Which one do you guys want to do? Let's read over it quickly. So 5 and 6 have pictures, so I say it's easy. So let's look at 2, 3, and 4. You guys think 4? Okay, let's look at 4. A building 50 feet high casts a shadow 68 feet long. Find the measure of the angle of elevation of the sun. Okay, so the building should be across the ground. It should be the hypotenuse, or it should be straight up and down. Usually buildings are straight up and down. And that's where my 50 feet comes in. Okay, the shadows should be the hypotenuse or along the ground. Shadows form a hypotenuse. They go like this. Or they are flat against the ground. So the shadow's flat against the ground at 68 feet. Okay. So here's my right angle. I know it's with the ground of the building. Better be at a right angle or that building's not standing up straight. And we want to find the angle of elevation of the sun. It is the bottom corner. Okay, so how are we going to set this up? 68 is what to x? Opposite, adjacent, hypotenuse? And what is 50? Opposite. Which trig function uses opposite and adjacent? Tan. So the tan of x equals opposite. That comes first because it's TOA, O-H. So opposite on top, adjacent on the bottom. Okay, so we take our handy dandy calculator, go to that inverse trig function. And we're going to go 50 divided by 68. I get approximately 36.33.
Why is the line of
The x has to go here because I have to know that I'm looking for an angle. And the x matters if it goes here, right? Because then this would be the opposite and this would be the adjacent. Right?
So you find what's opposite and adjacent like this.
Correct. Really good questions. Okay. So you only have 4 more of these to do, but you have a second sheet. Okay? You have a second sheet. So your second sheet, looks like, looks like this. And you guys, these ones, they might be trig inverse functions, they might be regular trig functions, or it might just be simply Pythagorean theorems. And I believe there are, how many of these? 1, 2, 3, 4. There are 9 problems for those. So 9, 10, 11, 12, 13. So you just have 13 problems. You have the rest of the class to work on them, plus homework time. I do want to look at this graphic organizer. This might be something that is really useful for you for tests and quizzes and for going over things. Okay, so I'm looking right here at theta, and I'm listing all of these, what they are. This is hypotenuse, this is opposite, this is adjacent. Now, this one, the angle changed. The angle's at the bottom. So I know that this is still the hypotenuse, but now this is opposite, and this is adjacent. Trig ratio, some of you guys don't like SOHCAHTOA. So you can know that the sine of something is opposite over hypotenuse. I still write SOA. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, might be a good, helpful memory. The blank of an angle and the blank of its blanks are relationships of trig functions. So, the opposite of the angle and the adjacent of its angle are tangent.
The opposite side of the opposite, or the adjacent side.
The opposite side of an angle and the adjacent side of its angle, yeah. Okay, let's look at the back. We would just label opposite of angle A, adjacent of angle A, and label the hypotenuse for all of these. It's just talking about some of those relationships. Okay, so let's look at this first one. If we're looking at A, opposite of A, adjacent, hypotenuse. Right? For this one, we've got A, we've got opposite, and adjacent. And this would be the hypotenuse if angle C is 90 degrees. It doesn't show in that picture. Does that make sense? This is just a little thing. A lot of people are having trouble with opposite and adjacent and hypotenuse. I want to make sure they're really clear. Okay. Think we are all set. I am going to